Okay, so we will touch on the topic of safety relay, what you need to know. So for the agenda today, we will look at safety relays versus standard relays, the benefit of using safety relays, and also relevant standards and risk assessment guidelines for a safety system, and choosing the right safety relays for your application. So followed by the last, which is our Q&A. So for now, let me start on this safety relay versus standard relays itself. So what is a standard relay? So for standard relay itself, it's actually a normal relay that uses a wire coil and the mechanical movements of metal contact to switch the load on and off. So what's the function of this? They are typically used to control and switch in power circuit, signal circuit, and also automation systems, such as controlling motors, heaters, lights, solenoid valves in industrial, automotive, and consumer electronics. So, but you all know there are actually in lots more industries than this, and they are also even in consumer products, which is such as irons and also air cons as well. So we also look at what are some of the issues that could happen with this standard relays itself. So the metal contact inside relays may weld after repeated operations, and this is actually called contact welding. It's actually quite often it happens. And if this happens, the machine will continue running when the operator press the e-stop buttons or any buttons for that matter. This places the operator in a hazardous situation. So I think a lot of people will question, oh, this seems like a very uncommon incident and usually it will not happen. However, I think we have a Murphy law that states that anything that can go wrong will go wrong. So please take note of that, which is why many standards, such as the international standards and safety standards, actually prohibits the use of any simple relays and contactors on hazardous machines itself. Okay, let's look at also what is safety relay. So it's just a relay that is used to execute safety functions within a machines or industries. So these safety relays must meet certain requirements such as EN 6094-947-5-1 or EN 60204-1. And they must also use to monitor the following safety functions, such as e-stops, safety gate, light curtains, 2M controls, or time delays. So we also have to take note that each of these safety relays can only control one functions of this. So imagine you have two functions you need, example, an e-stop and a safety gate. You would need to have two safety relays. You are not able to connect more than one functions to one safety relay itself, unless it's built for this. Usually they are single, okay? And of course, if we connect multiple, example, safety gates into one safety relay, it could also affect the performance level or the seal level itself. So this one is something to take note of. And also the relays must meet the following safety requirements. The circuit is, that means the internal circuit itself is redundant with built-in self-monitoring, and the safety device remain effective even in the case of a component failure. And the correct opening and closing of the relays on the safety device is tested automatically in each on and off cycle itself. Okay, so let's look at some of the comparisons itself. So we'll look at what these two relays, what's the differences. So one of them is the purpose itself. Of course, we already know the purpose. This is mainly for safety operations itself. And for standard relays, it's meant for just control and switching in all these products itself. And the next is actually the safety functions that it can actually control. So this one, of course, safety relays can control quite a few safety functions, whereas a standard relays have no safety related functions. They are only meant for switching power or signal on and off. And of course, certifications and standards itself, they do comply, and standard relays have non-compliance to any of the safety requirements itself. And diagnostic features. So just take note, safety relays does have self-checking, fault detections, and feedback monitoring to detect any faults, whereas standard relays have no advanced diagnostic features, and they usually require external monitoring or testing to detect any faults or failures itself. And the reliability for and failure modes of this, they are actually built in with a redundant circuit, self-checking functions, and force-guided contacts to minimize the risk of failures itself. whereas standard relays does not have any of this reliability comparative to safety relays. And they are definitely not suitable for any critical applications itself. Okay, so we will also look at this safety charts itself comparison. So one of the things we look at is the sizing. So for safety relays, they're actually big size, and normal relays, they can have different sizings itself. And a safety relays have a lot of force guided, they are using force guided contacts itself, using like logs, positive or captive guide contacts itself. For normal relays, they usually have electrically conducted metal pieces itself. And safety relays usually come in few colors, such as yellow or red even, whereas normal relays can be any colors they want to be. And of course, safety relays also have different functions like switching, indications, and protection. So this is actually normal. So, and then for normal relays itself actually mean for switching within a control circuit. And also the relays can actually make arrangement of circuitry switches itself, whereas the relays, standard relays only is connection of the contact itself. Lastly, safety relays are known to be more expensive, whereas normal relays is less expensive. Okay, let's look at some of the key points that is summarized just now by me. So safety relays and standard relays is for different functions. So one of them for sure is for safety. The other one is actually meant for standards itself. So for safety itself, we actually use it for like e-stops and safety door switches. Okay, so and then some safety relays actually cannot be used for functions like light curtains. So please take note there is different functions of each of these safety relays even. So it doesn't mean that you buy a safety relays, it will be able to use for everything. Okay. So there are different types of safety relays as mentioned. So please choose the right one. So if you're not sure, please ask the expert itself. And using standard relays for any safety functions will have serious consequences as mentioned previously. Same using PLCs for safety will have similar impact itself. So one of the things I need to highlight more is that, example, if you are using PLCs, and then if there is a problem happening, we will not be able to diagnose it, and the fault can occur. So it's similar to a standard relays. This tool has very, very similar functions, which is why it's not recommended for us to use a PLC for any kind of safety functions. Usually, but it's quite a standard practice or quite a common practice in our industries, in our region here, in Asia Pacific regions, for us to use PLC to control the safety functions as well. So this is actually not recommended, and there's usually a reason why. Okay, so I've explained that. So with this, I would like to hand over to my colleague Daniel, who will share with you on the benefit of using safety relays. Daniel, please.
Yes, thank you, Thomas. Okay, great insights. So now I want to show you some benefits of using safety relays. And the thing is, when we take so I got noted. No, just also a hiccup now. Okay, so thank you. Showing the benefits of using safety relays. And for that, we just take a look into a safety relay. So as you see here, there is a lot more than just one force-guided relay. So this is more than one component. So what you see here inside a safety relay, there is all these components wired to a specific circuit to make the safety easier. And when we just look about the invention of safety relay and when they're on the market, beginning of the late 1980s, there is before that all the safety relays coming to the market, you needed to just wire all this together by yourself with at least 3 force-guided safety relays. You need space in the cabinet, a lot of wiring, and in addition, each circuit you wired for each function had to be checked and certified individually. So when the safety relays are coming to the market, all this was no longer necessary because you get all this in one single device who can handle the safety way easier. So let's just make a deep dive into, let's say, the magic of the safety relay and how it works. So now you see here the input circuit. So we wired here an e-stop. Here is the plus voltage. It goes from the safety relay, and here the safety relay, there is the e-stop wired, and we're going here to the force guided relays K1 and K2, and when these are energized and closed, then you have here the contacts for wiring, let's say a robot, a saw or something else to enable to start or cut off the power, in other terms, the hazard. Here is the start circuit. So also here with the supply voltage, you have here an on or a start or reset button, which goes over the feedback loop. We just wired it here for simplification, very easy. Over the contacts of K1 and K2, these are normally closed contacts, to the safety or through the force guided relay K3. And the K3 has contacts into for the channel 1 and for channel 2 of the input channel. So now for the simplification of how it works, we can just push now the on button. And what I say, it's just so we're just doing it the simple way. So when you push the on button, the K3 will be energized. So when the K3 here over this button and the feedback loop will be energized, as it is a force guided relay, then every contact closes and every contact opens simultaneously. So these two contacts, the K3 in the input channel, are closing now. And because they are closing over the e-stop, K1 and K2 will be also energized. So now all three of these relays are energized. Because K1 and K2 are energized, in this path, K1 and K2 are opening and K3 will be de-energized. Also, this will open. And then we got a self-retaining system that K1 and K2 are self-retaining themselves. So, and because these are now energized, then these contacts are also closing, and then you have the enabling circuit active for a robot, saw, something else what you want to wire. And this is the state when the machine is now running. Everything is fine, everything is running, everything is safe. So now, in an event of a hazard or something else, some of the operators are pushing now the e-stop. And what will happen now? If you push the e-stop, the input channel will open, and in an instant of time, K1 and K2 will be not energized anymore because they do not get the supply voltage. And because that, they are de-energizing and open every contact. So they open the K1 and the K2 contactors. That's why the enabling is, or the enabling path of the robot, saw, whatever, is not active yet, and the machine stops if everything is wired correctly. But the safety relay is doing its work, its magic, let's say. And so, and now if the danger zone is free again, everything is fine, then you release the e-stop, the input channel is active in this case, and then we are right at the beginning. We have to push start or restart, that we get over the feedback loop, the K3 active, and everything starts again. So what you see here, we have here K1 and K2 wired in line. So let's say in a row. So this is the redundancy. So, and what is the idea behind that? And let's take a look in our everyday life. Everyone of us has a mobile phone. We take pictures of friends, family, vacation, and most of us have stored them in addition in the cloud, let's say Google, Apple Cloud, or have a cloud setup system by ourselves to just store the pictures, the taken pictures in addition. So this is our backup, our safety net. And that is here also with the redundancy. We have a built-in redundancy. As Thomas said, there are some possibilities, faults if the contacts are welding and then you are just pushing the e-stop, then it could be that if we have welded contacts, K1 would still be de-energized but does not open. But therefore we have the K2 and still the K3. So everything is fine. That is the built-in redundancy, because if one of them has a fault and the other not, the safety relay will still just take away the enabling or cut off the voltage, the power of the hazard as a robot or something like that. Then, of course, we have a real-time fault diagnostic. If you just remember the picture, I just showed what everything is wired in there, and I said this is a very simple way or a simplification of the working purpose. Then it is just like, how do you diagnose it? And with the safety relay, you have real-time fault diagnostic. You have many LEDs. In this case, we took the PILS Pnot Sigma S4 as an example. You have 6 LEDs and they display all the signals and faults in the complete safety circuit. So with that, it is much faster than with conventional relays. And the built-in monitoring of the input channel, supply voltage, the relay outputs is indicated by this relays, and this enables fast and real-time diagnostics, and all without the need of an additional external measuring device. You see at a glance if it is working or not, or where to diagnose. And this is just, of course, very time consuming if you have to do that, but the safety relay will help. So then you get a maximum flexibility. So let's take again the Pnot Sigma S4 as an example. So we have here a small selector switch, a rotary switch. I just make it a little bit bigger than you see. And with this selector switch, you can just select your operating modes as for starting and for monitoring. So you get for this a maximum flexibility inbuilt and without need for additional wiring. So with this operating mode, you can make an automatic start or manual start, as I showed in the example. This was then a manual start because you have to push the button, and we have detections for short contacts or not. So if channel 1 and channel 2 has a short or a cross against this contact, the safety relay will recognize that and will go to a safe state. And there are plenty of operating modes you can just select from that. Then again, also Thomas said it is fail-safe for the operation, and it has a self-monitoring. So it monitors by every restart from itself if everything is okay, if the contacts are correct inside, if the wiring is okay according to what you just switch for the operating mode. It will also detect if there is a short, if there is a cross, it's there. So, and if you, and this is also a very good thing, if you wire from these input channels, let's say, for example, the e-stop, the S4 or most of the safety relays will emit so-called pulses for the connection of the safety input. And these pulses are used to detect possible faults. So for example, if a short or cross circuit arises in the input circuit, the safety relay recognizes it and switches to a safe state. And the safe state is de-energizing every relay inside. So there is no enabling path. It is the same as it if it has no power. Then when it comes to the standards, also Thomas said there's standard compliance. So if you are a machine builder and you build machine for your own country and you want to export machine to other countries, these machines must comply to certain standards. And of course, we have many international standards, but we also have local standards. And these local standards are sometimes adopted from these international standards, and some also are harmonized. So for Thailand, Singapore, Malaysia, and Vietnam, we have some specific acts. Let's say for Singapore, we have here the Workplace Safety and Health Act from 2006, which would take care about all these standards from what the machines have to comply with that. And these safety relays, as you also know, if you want to export it, they got some markings, and also the machines like CE marking from Europe, Triple C, China, UL listed for the US market. And all the safety relays just came with that. So at a glance, the benefits of using safety relays are many. I just mentioned some of them. We have a built-in redundancy, real-time fault diagnostics, fail-safe monitoring, operations, self-monitoring. They're compliant to standards. You save time and space. You have maximum flexibility. And how to say, in safety relay is therefore, because in an event of an hazard, the safety relay will work to reduce the risk to an acceptable level. That's it. Or in other words, let's say for machine manufacturers, the safety relay gives you the certainty of a holistic, safe, functioning, tested, and certified device. And on the other hand, for machine operators, the certainty that the danger zone is safely and redundantly protected in the event of a fault.
Okay, just a question, Daniel. You mentioned several standards earlier, and also you mentioned that the safety relay will reduce risk to an acceptable level. What actually is the acceptable level, and how do we achieve that?
Oh, with that, I think I can answer that. So let me move on to the next sector then. So I will touch
Okay.
on actually the relevant standards and also some of the risk assessment guidelines for a safety system. So just now, as mentioned by Daniel, we do have quite a lot of standards. I will go slightly into depth some of the standards itself. So one of them is the EN 60947-5-1. So this is actually general rules related to control circuit devices and switching elements where rated voltage does not exceed 1000 VAC or 600 VDC itself. The next standard that is compliance is EN 60204-1. It's actually a safety of machinery, electrical equipment of machines. The next one is actually the IEC 62061, which is actually touching on the seal level. What this does is actually specify some of the requirements and make recommendations for the designs, integrations, validations of safety-related circuit control systems for machines itself. And this is actually very similar with the ISO 13849, which is talking about performance level. So this states the similar things, including additional of designs of software itself. So let's look into both the seal level and performance level slightly more in depth to understand more later, but we will now look at the regional relevant standards. So for Singapore, so as mentioned, WSH Code of Practice. So this one is SS537. This is talking on this Code of Practice for safe use of machineries for Singapore. And for Malaysia, this is actually using of the MS in front of the ISO. So they are actually a bit harmonized standards. So they also have the 13849 as mentioned. And for Vietnam, they're using TCVN. So this is the TCVN 7383, which is actually talking about risk assessment. TCVN 7384-1 is talking about ISO 13849. And lastly, for Thailand, it's all harmonized with the ISO as well. So as mentioned, I'm going to touch on more on the seal and performance level. So what are they? They're actually a simple band of probabilities of dangerous failure. So I will show below what exactly it means. So one example performance level B is equivalent to still level 1, which is having the average probability of dangerous failure per hour under this band itself. So for performance level E itself is actually to this band, and you can take note this is actually still level 3 itself. But take note the correspondent is not exactly. So it is, you have mentioned, you notice there could be a missing still 4. So they don't have a still 4 representative for performance level, and there's no performance level A representative for still level as well. So this is some of the correspondent that's not exact. So I will look into more in depth for this still level currently. So looking at this table itself, this is actually a still level table itself. So we will look at a few key factors. One is actually severity, and also then we'll look at class itself. So we need to know this, and of course, you will also mention the consequences for this as well. So let's look in depth for this. For consequences, the death example, death, losing an eye and arm, is actually severity 4. And then permanent injury of losing a finger is severity 3, with reversible injury, medical attention, 2, and then reversible injury just with first aid is actually 1. Then we need to look into the FR. What is FR? Which is frequency of durations. So for the frequency of durations, there's 2 parts to look at. One of them is to look at how frequent are you exposed to this risk itself, and then how long is the duration? Is it lesser than 10 minutes or more than 10 minutes itself? Okay, so the next one we look at is PR. What is PR? Probability. So it's the probability of occurrence. So it has from very high to even rarely or negligible. Okay, accordingly. And lastly, look at AV. So what's AV? Avoiding and limiting self. So the probability of avoiding or limiting. So is it impossible, rarely, or probable? So this is the few ratings for this. So let's have an example. Okay, example, I will look at SE3, which is the severity 3. So we are looking at something that can actually, let's say a machine that can actually cause a permanent injury or losing a finger. This could be a robot example, okay? And then we look at what are the FR itself. So if we term it that we will be only expose it less than 1 per hour, but more than 1 time per day, and the duration will be less than 10 minutes, I will take this rating of 4, okay? And let's say I think the probability of occurrence is likely, so I will take then 4. And then the probability of avoiding is actually rarely, because it's not too often. So then I will take 3. So with this, we add up together 4 plus 4 plus 3 is equivalent to 11. So we look at this table then. So the severity we already chosen is 3 and then 11. So this will then be in the band of still 2 and performance level required of D itself. So this is just how, so this is the requirement you need to meet for your machinery itself. So this is how to choose which safety relays to use. So if you have to choose, you have to choose a performance still level 2 or a performance level D and above safety relay. Okay, or any safety products for that matter. The next one, we will look into that more on the ISO 1349 for performance level itself. So this is very, very similar to ISO itself, but it has lesser brackets for the some of these sectors itself. As you can see, there's usually only 2, 2, and 2. So let's look at it. So the first one is actually severity of injury. So it's S1, S2, which is slight injury, normally reversible, or serious injury, including death, normally irreversible. And then the frequency itself is F1 is rarely to often and short duration, or frequently to constant and or long duration. And then the last one is probability of avoiding the hazard or limiting the harm, which is P1, which is impossible in certain conditions, or P2, almost impossible. Okay, so let's have an example of a robot example again. So for a robot itself, normally if in industrial robot, it could actually cause some serious injury. So we look at here as S2 for start, and then for frequency and exposure durations, let's say I am quite frequently exposed to this because I'm working with it. and it's for long durations, I can choose F2. And then is there a possibility of avoiding? Yes, I can avoid it in certain conditions. So it's P1. So then the performance level required will be then performance level D. So take note, the higher the letter, the more high risk for this thing itself, which means that the component needed, the safety component needed is actually better quality with better diagnostic and functions to actually address all the faults itself. Okay. So other things to look at will be also um, architecture of the safety functions. So single channel safety functions itself, one single fault can lead to loss of safety. So it's Cat B is normal control. Cat A is well-tried safety components. Cat 2 is with testing itself. So this is one of the examples with single, B and 1 itself. And then this is Cat 2 itself with testing. And then for a dual channel safety system, this one single fault does not lead to the loss of safety. So this is Cat 3 dual channel. So this with dual channel system itself. And then Cat 4, this one is dual channel with diagnostic and to prevent loss of safety with second fault itself. So please take note for the loss of safety with second fault, we will need to have only if the feedback loop is evaluated for this. So then you can achieve category 4 itself. So this is roughly how we do the architecture of this. And then now we look into that more on the performance level to gauge what performance level it is. So we need to look at a few factors. So you look at this color coding here, green color, yellow color, and red color itself. This is represented in this chart, okay? And this is mean time to dangerous failure itself. So it could be low, medium, or high. So to take note of this. The next one to look at in this chart itself is also diagnostic coverage. So this diagnostic coverage could be none, low, medium, or high, which is all rated here. And also one thing you have noticed here is the category. So this was mentioned just now in the architecture itself. So it could be Cat B, Cat 1, Cat 2, Cat 3, or Cat 4. And there's one thing to take note, which is our common cause failure itself. So CCF itself is actually a general score that you need to achieve more than 65% to be able to ascertain that this circuitry is actually passing the level itself. So usually most people can achieve 65 by looking at the physical separations of the safety circuits and other circuitries. So you want to separate the circuitries, you will get 25 points. And using different technologies, meaning diversity, you get 38 points for that. And then design applications and experience, you have 2 points. Assessment and analysis is being done, you get 18 points. And you're actually competent and trained, you get 4 points. And other like environmental influence, you get 18 points. So you just need to achieve 65 points out of all these 100 points to be able to ascertain that what you have chosen here is actually correct. So let's do an example. Okay. So we want to have a performance level target of D. After going through just now the chart, we feel that, oh, okay, my robot is actually D. Okay. So I will target D. So how do I achieve target D? You can see this area here. These are all things that can help you achieve D. Okay. So for MTTFD, medium to high. So it's MTTFD, which is this, medium to high. So this is high, high, and then sometimes medium and high you can achieve as well. And then for DC average itself is low or medium itself, but it depends on where you are. So for Cat 3 itself, you have an average diagnostic of low, and with MTTFD of high, you can actually achieve almost level D. So also you must actually achieve also CCF, 65% and above, to be able to confirm that your circuitry actually meets this requirement. Okay, so it seems very complex, and actually quite a number of people will actually get a bit lost during this kind of looking at this kind of performance level and ISO 1349. So this is something you can actually check to experts like us for all this advice. Okay, so what is some of the key summaries to look at? Okay, so there are many relevant safety standards in the market itself. Okay, as mentioned just now, there's quite a few standards, and it's not easy for everybody to know and every one of them. And what's the details inside that? And actually, even if you have the detail, what does it actually mean? So it's very complex. So if let's say you're not sure, that's actually best to actually check to us, okay? So there's actually two main ways to achieve safety system itself. So it's actually using the seal and performance level. But apart from this, actually other factors you also need to consider inside a safety system. So things such as fault masking, or in the drop of the performance level due to series connection and all these things. So it's not easy to just rely on this performance level, just now as mentioned, to just come up with a system. There are other factors to actually take into consideration as well. So also take note, for a safety system to achieve a certain safety levels, example, we take a D example, okay, it must incorporate safety into their whole line. So people always assume, oh, I need to have a door switch, I just need to have a safety relay, I'm done. Actually, it's not true. We need to have the safety system inside the whole circuitry. So it includes what? Input systems, such as your door switches to your light curtains, to the logics, which is your safety relays or safety controllers, example, and also to your outputs as well, such as contactors or equivalent SDO to meet the requirements. So just imagine you have a performance level of E for your input, performance level E for your logic. However, your output is performance level B. Your highest performance level you can achieve for this whole circuitry is actually performance level B. And if your output or whichever portion of this is there's no safety, example, you are using PLCs to control your logic itself, automatically your circuitry of your input and your output, even you have achieved performance level E, it will drop to no performance level. So it will not be a safety circuitry at all. So you can't say that I'm a performance level something, okay? So this is something very important, take note. And everything must start from somewhere. So it must start from a risk assessment. A risk assessment help you assess what is the risk that your machine is having. With this risk itself, you will know which level to reach. So we have a way to look at a quick table to look at it. So you need to know the limits of the machinery and then the hazard identification, the risk estimation, the risk evaluation. So you evaluated the risk already, and then is the machine safe? If it's not safe, you need to reduce the risk. If it's safe, then we can end it. Okay, with that,
Okay.
yeah.
Thanks, Thomas. Thank you
Yeah.
for sharing how to achieve a safety system based on different standards. Just another question. Actually, we have one question from the audience. So we all know that we have a lot of safety relays in the market, right? So here comes the main point. Like, how do we choose the right one for the application that they need?
Yeah, perhaps I can jump in this case. And on one hand, it is just like to contact pills because we are have a very huge experience on it. But also we have, let's say, make a guideline, so walk through choosing the right safety relay for your application or for your needs, that you get the solution for what you want to do. So as Thomas said, as first, it must start somewhere with the risk assessment. But when you've done it, then you know what is the risk area, the danger zone, the hazards, and then we have to look on, okay, how can we handle that? And that's come to the point. And one of the first questions is, do you need, let's say, several working areas, working zones, or which safety function? So if we can answer this, we at first have to understand the zones. So what is a danger zone? And a danger zone is a zone with or in or around a machinery in which a person is exposed to a risk of injury or damage to the health. And I will show you something. This is just an example of a machine. It is a palletizer. And we have now there are two working zones. One is the yellow one, and one is the blue one. The blue one is protected with one light curtain, and the yellow one is protected with two light curtains and one safety gate. Overall, we have one common e-stop, which is here. So according to these machine, and the safety zone is that in, let's say, in the yellow zone, if there is here a package is dropping and the worker is just opening the safety gate, if the robot is working here and not bypassing this or these light curtains, the machine is still working because there is, even the door is open, the operator is not exposed to a risk of injury for his health. But when the robot now is just bypassing the light curtain, then the machine will stop. In the blue working area, these pelletizer, or what it does with this board, is still working because he can't go inside. On the other hand, if these pallets are empty and there is a forklifter coming by, then he is bypassing this light curtain. The machine here stops in this working area, so the forklifter can just put new pallets inside, but the robot, because safety gate is closed and everything else, will still work on palletizing the packages. So what does that mean now? So if you have a machine with several working areas or danger zone, you can separate them, and the machine can still work in these areas so that the worker is not exposed to that. But what does it mean on the end? This is the all affecting the OEE, the overall equipment effectiveness. And the OEE is much higher for a machine with several working areas than with only one. And with this in mind, we can say now, if you want to have the need of several working areas or zones, then the best fit is the MyPnots, the MyPnot system from Pilz. So what is the MyPnot system? The MyPnot has several features. It is a modular product. We have a variety of modules which can be plugged together with the connectors, and it enables all the input function you can just imagine, like safety gates, e-stop, everything with OSSD inputs. We have special modules for locking devices, and all these can be ended or ORed together into specific zones and working areas. And we also have very good diagnostic for that. The process how to get to the MyPnots is that we also have a web-based, let's say, creator where you can just put your solution in there with the the several safety functions and how to they interfere with it. Let's say these are ended or ORed and linked together with delays, and then you can simulate it on the computer. And if you're done with it and satisfied, then you can order it, and Pilz does it in a batch size of 1. So your solution will be produced, assembled, and tested just for you, and then delivered in the box. And it will also be comes with a wiring diagram, so that you just can, let's say, have a very easy installation. You take the MyPnots, put in the control cabinet, wired and like the provided wiring diagram, and then you're done. It's plug and play. And since you tested it and it comes from your solution, it works. Very easy. On the other hand, if you say, no, I do only have one working area, one function, then the question is, do you need an expandable safety relay? So in the example, 20 minutes before, we see that we have 3 safety contacts. If you need more, and then this is the question, yes, you will stick to the Pnot Sigma. Pnot Sigma has the benefit of expandable safety contacts, so you can expand them and multiply them with additional modules. If you say, okay, no, I do not need that, but I have a specific supply voltage, which is not the 24 standard volt DC, but let's say 48 volts DC in AGVs, or 230 or 110 volt AC, then The question is, should it be possible to set the parameters with a rotary switch I also showed before, or is that not needed? If yes, then also Pnot Sigma is the best fit because it handles everything. If you do not need these parameters, just a possible set because it's clear that you only want to have a start or an automatic start or no cross-check with pulses or a short, then the Pnots X is your best fit. So if you only need, let's say 24-volt DC, and you need a very specific design, a very compact design because your control cabinet is not that big, then the Pnots Compact is your best fit because it's smaller in width and size. If you say, doesn't matter, it mustn't be a compact design, then you can also go with Pnots X and Pnots Sigma because they handle everything. So coming to the different product families I just mentioned, the Pnots Sigma, Pnots X, and the Pnots Compact, the Pnots Sigma is the most versatile one. So we have a maximum functionality in a minimum width, starting with 12.5 millimeters. It is configurable, it has many reset functions, also time delays. We have standardized terminals, so the wiring will be very easy. It is modular and scalable, and of course, with expandable safety outputs. The Pnots X is, in this case, we have safety for every function. It is not that with that high functionality that you can just configure it. So you have to just buy one, and if you need another function, you have to buy another. We have electromechanically potential-free contacts, and of course, multi-voltage power supply. And the Pnots Compact, it's mostly the optimal choice for high volume machine manufacturers. Inside there are basic safety function, only 24-volt DC, and it's also capable for single channel. And these are the product families we have, and inside there are many safety relays. So, and this is just the guideline where you can go through, and then you go to, then you land in a specific product family, and then you can choose the safety relay just according to your needs.
Okay. Thank you, Daniel, for that insight, and thank you to Thomas as well. I think we have come to the end of our presentation, right? So we have it's time for Q&A. We have a few questions already in the chat box. So if you have other questions, please type it in now. So first question for our speakers, how many types of safety relay is there in the market? I mean, we can't say for sure, but do you have any idea?
Yeah, there are many, and as you said, there is an ocean of safety relays. So in this case, also Thomas said you have to look what you want to have at the input channel. So mostly you can say there are safety relays who are capable for emergency stop, safety gate, and safety switches in as one, and then there is sometimes an additional safety relay which is doing the same but for an OSSD input channels. And then you can say for the output is that you have safety relays which are non-delayed and delayed. So in this case, I cannot tell you any number, but let's say these are these four types. So OSSD or non-OSSD and delay or non-delay output channels. So in this case, they are the big variety. We have seen that there is some safety relays which are only capable of e-stops. We have seen there are safety relays which are capable of everything. The MyPnots is, in this case, not a safety relay by itself, but it's like a safety, modular safety solutions, because you can address many safety functions and working areas. So also a little bit a different approach, but the same because it combines many of them. Yes, I hope this answers the question.
Okay, thank you. Next question. Output contact consists of safe and auxiliary contacts. Semiconductor output consists of safe and auxiliary outputs. What is the difference between the two applications?
From the safe contact and the auxiliary contacts, then there's the difference that, as I said, the safe outputs are safe and the auxiliary outputs are not. So it is about the redundancy. And normally the auxiliary outputs will be used for indicating a lamp or something else, so that you can see if the safety relay is working or not, or the working area is in this case active or not active, or there's someone who is exposed to danger. Referring to relay and semiconductor outputs, in this case, both are safe. Relay are a little bit faster, but you have there aware. So with the matter of time, it is because you have all these energizing, de-energizing. This is a bit tricky, and let's say after 20 years or so, you have to change the safety relay, and by the semiconductor outputs, you do not have a wear. So if you have an application where you have, let's say, in 1 hour or 1 day, a high amount of opening and closing contacts, then the best fit would be a semiconductor output. And if not, and everything is fine, perhaps you have a little bit, want to have also a little bit less in wiring efficiency, then you stick to the relay contacts.
Okay, I hope we answered your question, Pak Ur. If not, you can always contact us again. Sorry. Last question, I think, because we ran out of time. So, how can we learn more about PL and SIL and architecture of safety systems? Just now you shared earlier, I think, Thomas, your part. How can they learn more about PL, SEAL, and the
Oh,
architecture of safety
performance level and
systems?
skill level you're talking about.
Yes.
Okay. Sorry, I
Sorry,
didn't
I
catch
used
that.
PL and
Okay, how can you learn? Actually, we do have training courses for this. So it is covered inside some of our fundamental machinery safety to our CMSE courses itself. And these are usually part of the modules itself to cover this. So that's one way you can actually learn from it. If not, there is other ways to actually learn this, or you can actually get advice from us, our safety experts itself. They can actually help you do this designs or all these things without you yourself needing to know this, because since they are experts, they will help you to do it. So there's quite a few ways. One more way, I do also offer some free seminars that touch a little bit on this. However, it's not going to be in depth like the actual paid course itself. So if you really want to know more, please attend our courses, like the CMSD, which is very, very good. So that could be one of the ways to do it.
Okay. Thank you very much, speakers today, and thank you to everyone who attended the webinar.